Astronomers confirm fifth exoplanet in L9859 system. A habitable super-Earth. A cosmic neighbor just got more interesting. Scientists discover a potential water-friendly world in nearby star system. But here's where it gets controversial. Could this compact system of 5 planets around a tiny star truly host life? Let's unpack the discovery that's rewriting what we know about alien worlds. Astronomers have confirmed the existence of a 5th planet in the L9859 system, a red dwarf star located just 34.5 light-years away, practically next door in cosmic terms. The newly identified world, named L9859F, is particularly intriguing. This super-Earth-sized planet, weighing at least 2.8 times our world, orbits within its star's habitable zone, where liquid water could theoretically exist. Unlike its siblings that pass directly in front of their star from our perspective, L9859F plays cosmic hide and seek, requiring sophisticated detection methods to confirm its existence. Here's why this matters. The L9859 system now boasts one of the most diverse planetary collections we've found. Imagine a cosmic family portrait featuring 3 inner planets zipping around their star in less than a week, including one smaller than Earth, a middle planet with mysterious composition, the new outer world that might have just right temperatures. And this is the part most people miss. These discoveries didn't come from a single telescope. Researchers combined data from NASA's TESS space observatory, the European Southern Observatory's ESPRESSO instrument, and even early observations from the revolutionary James Webb Space Telescope. This cosmic detective work revealed precise details, like how the innermost planet is actually 16% smaller than Earth, while another weighs in at exactly twice our planet's mass. And controversial alert, some scientists argue red dwarfs like L9859 make terrible hosts for life. These stars are notorious for violent flares that strip away atmospheres. Yet the team found these planets follow nearly perfect circular orbits, a stable configuration that might help preserve any potential atmospheres. Could we be looking at the Milky Way's ultimate survivors? What makes this system extraordinary isn't just the numbers, explains lead researcher Charles Cadieux. It's our first real laboratory for comparing Earth-sized planets with different compositions. One might be rocky like Mars, another a water world, while others could have thick Venus-like atmospheres. The burning questions now? Professor René Doyon highlights the big mysteries. Are these super-Earths actually habitable? Do small stars create different types of planets? And the million-dollar question, could any of these worlds right now be harboring atmospheric gases that hint at biological activity? Here's where you come in. Do you think we should prioritize studying these nearby compact systems for signs of life, even if the star seems temperamental? Or should we focus on sun-like stars instead? Drop your thoughts below. This debate could shape the next decade of space exploration. The full findings, published in Astronomical Journal, represent a major leap in exoplanet research. With Webb telescope atmospheric studies already planned, we might soon know if any of these worlds are wearing the cosmic equivalent of a Hello Universe t-shirt, detectable signs of air, water, or even life-friendly chemistry. Super-Earth exoplanet 35 light-years away could support life. Imagine a world where life could thrive beyond our own planet. This intriguing possibility is brought to light by the recent discovery of a 5th planet located within the habitable zone of a star just 35 light-years away from Earth. This exoplanet, known as L9859F, has sparked excitement among scientists due to its potential to support liquid water and perhaps life itself. L9859 is a cool and dim red dwarf star, already recognized for hosting a compact system of small, rocky planets. The latest findings, spearheaded by researchers from the Université de Montréal Trottier Institute for Research on Exoplanets, confirm the existence of L9859F, a super-Earth with a minimum mass that is 2.8 times greater than that of our planet. This discovery is significant because it adds to our understanding of the diverse types of planets that exist in the universe. The newly identified exoplanet orbits its star in a nearly circular path, completing a full revolution every 23 Earth days. It receives a similar amount of stellar energy as Earth does, placing it comfortably within the star's habitable zone. This zone is a critical area where conditions may allow for the existence of liquid water, provided the atmosphere is suitable. According to a statement from the university, this finding is particularly thrilling because it showcases the remarkable variety of exoplanetary systems and underscores the importance of studying potentially habitable worlds around low-mass stars. Charles Cadieux, a postdoctoral researcher and the lead author of the study, expressed his enthusiasm, stating, "Finding a temperate planet in such a compact system makes this discovery particularly exciting. It highlights the remarkable diversity of exoplanetary systems and strengthens the case for studying potentially habitable worlds around low-mass stars." The discovery of L9859F was made possible by reanalyzing data collected from the European Southern Observatory's HARPS, High Accuracy Radial Velocity Planet Searcher, and ESPRESSO, the shell spectrograph for rocky exoplanet and stable spectroscopic observations, spectrographs. Since this exoplanet does not transit or pass in front of its host star from our viewpoint, astronomers detected it by observing subtle changes in the star's motion caused by the gravitational influence of the planet. By integrating the spectrograph data with observations from NASA's TESS Transiting Exoplanet Survey Satellite and the James Webb Space Telescope, JWST, and employing advanced techniques to filter out stellar noise, researchers were able to ascertain the size, mass, and essential characteristics of all 5 planets in the system. The study reveals that L9859b, the innermost planet, is only 84% the size of Earth and has half its mass, making it one of the smallest exoplanets ever measured. The tidal forces acting on the 2 innermost planets may lead to volcanic activity, while the third planet's unusually low density suggests it could be rich in water, presenting a unique case compared to any planet in our solar system. This diversity provides a rare opportunity to explore the formation and evolution of planetary systems beyond our own, as noted by the research team. Cadieux remarked, "These new results paint the most complete picture we've ever had of the fascinating L9859 system. It's a powerful demonstration of what we can achieve by combining data from space telescopes and high-precision instruments on Earth. And it gives us key targets for future atmospheric studies with the James Webb Space Telescope." Given that L9859 is relatively small and close to us, its planets are particularly well-suited for follow-up studies of their atmospheres. If L9859F possesses an atmosphere, telescopes like the JWST may be capable of detecting water vapor, carbon dioxide, or even potential biosignatures that could indicate the presence of life. This groundbreaking study was published on July 12th in the journal Earth and Planetary Astrophysics. As we continue to explore the cosmos, the implications of such discoveries are profound. What do you think about the potential for life on exoplanets like L9859F? Could we be on the brink of discovering extraterrestrial life? Join the conversation in the comments below. Diverse rocky worlds discovered. 5th potentially habitable planet found around L9859. Imagine a star system where 5 small planets orbit closely around a tiny red dwarf, their diverse compositions offering a unique window into the formation of our universe. Welcome to L9859, a fascinating planetary system located just 35 light-years from Earth. A team of researchers from the Université de Montréal, led by Charles Cadieux, has made a groundbreaking discovery in this system. By combining data from space telescopes and high-precision instruments on Earth, they have confirmed the existence of a 5th planet in the habitable zone of L9859. This zone is the region around a star where conditions are just right for liquid water to exist, making it a potential candidate for hosting life. But here's where it gets exciting. The 5 planets in the L9859 system are a diverse bunch. The innermost planet, L9859b, is a scorching hot world with a size and mass similar to that of Earth's moon. The next 2 planets, L9859c and L9859d, are thought to be volcanic in nature with extreme tidal heating causing volcanic activity similar to that seen on Jupiter's moon Io. Meanwhile, the 3rd planet, L9859e, is a water world with a density so low that it's likely composed primarily of water. And then there's the 5th planet, L9859f, which orbits in the habitable zone of the star. This planet is a super-Earth with a size and mass that suggest it could be a rocky world with a thick atmosphere. The discovery of L9859F is particularly exciting, as it highlights the remarkable diversity of exoplanetary systems and strengthens the case for studying potentially habitable worlds around low-mass stars. But how did the researchers make this discovery? The answer lies in their innovative approach to analyzing existing data. Rather than requesting new telescope time, the team relied on a rich archive of data from NASA's TESS Space Telescope, ESO's HARPS and ESPRESSO spectrographs in Chile, and the James Webb Space Telescope. By employing a novel line-by-line radial velocity analysis technique and a new differential temperature indicator, they were able to precisely identify and remove the stellar activity signal from the data, revealing the planetary signal in unprecedented detail. The implications of this discovery are significant. L9859 is now one of the most compelling nearby systems for exploring the diversity of rocky planets and searching for signs of life. This system's proximity, the small size of its star, and the range of planetary compositions and orbits make it an ideal candidate for atmospheric follow-up with the James Webb Space Telescope. As we continue to explore the universe and discover new worlds, we are reminded of the awe-inspiring complexity and diversity of creation. The discovery of L9859F is a powerful reminder that there is still so much to learn about our universe, and that the search for life beyond Earth is an ongoing and exciting journey. So, what do you think? Are we alone in the universe? Or is there life lurking on one of the many exoplanets we've discovered? Share your thoughts in the comments below.